Hi everyone, this problem comes from chapter 1.10, density using volume displacement. This problem tends to give students a little bit of a harder time because it's not your typical problem where you submerge an object and then it tells you the final and the initial volume, and then you go from there and solve for density or mass. Okay, but here it looks like you may not be given enough information or you're given a little too much information, but I'm going to try to go through here and explain to you what this problem is asking. Okay, so you have 200 mil graduated cylinders. Okay, so we're just going to, and they're filled to the 40. So they're filled exactly the same as water. Okay? And you have two cubes. One's lead, and one is aluminum. Okay, so we have two objects here. Of course, they're three-dimensional, but it says that it's 2 centimeters on each side. Okay, so after you carefully lower each cube into the water, what will the new water level be for each of these cylinders? Okay, and so a lot of students think, well, what's the centimeters telling me? How do I use this? Okay, if we remember that 1 milliliter is equal to 1 centimeter cubed. Okay, so we have a cube. So if we take length times width times height, okay, so if each side is 2, then we can come up with its volume. Remember, volume is equal to length times width times height. Okay, so we would take 2 times 2 times 2 will give us 8 centimeters cubed. Okay, and this means this is equal to 8 milliliters. Okay, so if you look back at this section, it tells you that when a solid is submerged in water, it displaces a volume equal to the volume of the solid. Okay, so we have come up with now the volume of the solid, and that is 8. So this is equal to the volume that will be displaced when we carefully drop these in. We're doing this in the lab. And so both of them have the same volume, so the water that is displaced is going to be equal for the lead and the aluminum. So it really doesn't matter. A lot of students don't see that you get the same volume for both, the lead and the aluminum. Okay, so it's not a trick question, it's just really making you think. So you have 8 milliliters, so what's going to happen is you're going to go up by 8 milliliters. Okay, so we started at 40, is that right? Yep. Okay, so we would have 48.0 milliliters and 48. But this is how you would put this in to mastering. However, it's not going to be the exact same. I think your cube is going to measure 1.6 centimeters or something similar to that. Okay, so you find the volume by taking length times width times height. You get 8. This is the volume of the solid, so when you drop the solid into the graduated cylinder, the aluminum or the lead, the water level is going to rise by that many milliliters, by that amount of volume. So both your lead and aluminum would have a volume. A new water level would be 48.0 milliliters for both. And this concludes problem 1.64.